Hello students, today we are going to discuss the second numerical of indeterminacy of beams. Question is written as find the indeterminacy of following beams for vertical loading and axially rigid member. It means that the beam is subjected to vertical loading only as well as the member of the beam is rigid. Okay. Now we want to calculate here what the total indeterminacy of this beam, that it will be the sum of external static indeterminacy, or we can just say that the total indeterminacy will be the sum of static indeterminacy and kinematic indeterminacy. Okay. Now for the calculation of static indeterminacy, we want to calculate external static indeterminacy as well as internal static indeterminacy. Now we know the formula of external static indeterminacy. It will be the difference of R minus S. Now what is R here? The total number of support reaction, which is here 3. That is vertical reaction at B, vertical reaction at C and vertical reaction at D, because these supports are simple supports. Now we have only two equilibrium conditions here, because for vertical loading there will only two equilibrium conditions in case of beam, that is summation of vertical forces will be equals to 0 and summation of moments equals to 0. We are not considering here the net horizontal forces equals to 0, because no horizontal force is acting on the beam, because the beam is subjected to vertical loading only. Okay. Now if we put the value of R and S here, then what will be the value of external static indeterminacy? It will be equals to 1. Now we know that if we know the external reactions, then we can easily calculate the internal reactive forces, that is bending moment, shear force and axial forces. So in case of beam, always the internal static indeterminacy will be equals to what? 0. Now if we want to calculate the total static indeterminacy, then it will be the sum of external static indeterminacy plus internal static indeterminacy. Then it will be equals to 1 plus 0, which will be equals to 1. Okay. Now we want to calculate the degree of kinematic indeterminacy. For the calculation of kinematic indeterminacy, we want to know the possible movements at each and every joint. Now in case of axially rigid members, at free supports or at free joints, there will only be two types of displacement, that is vertical displacement and rotation. In case of rigid structure, similarly at joint E, there will be vertical displacement and rotation at E. Okay. Now at each simple support, there will only be one possible movement, that will be the rotation. Okay. Now how many possible movements are there? 2 at support A or at free support A, plus 1 at free support, 1 at simple support at B, 1 at simple support at C, 1 at D, and 2 possible movements at free and E. Okay. Now if we do the sum of all these values, then it will be equals to 7. Now we want to calculate the total indeterminacy, then it will be the sum of static indeterminacy and kinematic indeterminacy. So we just add these two values, that is 1 plus 7. So the total indeterminacy of this beam will be equals to 8. It means that the total static indeterminacy will be equals to 1 and the total kinematic indeterminacy will be equals to 7. Now if we add both the values, then the total indeterminacy will be equals to 8 for this beam. Now that is the complete solution of this question. Thank you very much, students.